Hey, it's Mr. Redstone, and in this video we're going to solve a few more multi-step equations, but this time the solutions can be special cases. And if you don't know what I mean by that, well, stick around, you might learn something. In a previous video I showed you this acronym DCI, stands for distribute, combine your like terms, and then use inverse operations. So I've got brackets, let's get rid of them using the distributive property. I see I have negative 8 plus 6x plus 4x, that'll be 10x plus 5. So now I've distributed, I can combine my like terms. So I look on the left, I see I've got 6x's and 4x's. I can combine those to get 10x. Subtract 8 equals 10x plus 5. Well, using inverse operations, to get rid of an addition of 10x, I can subtract 10x. And what I do to one side of the equation, I do to the other to maintain equality. That leaves me with negative 8 equals 5. Pretty sure they're different numbers. They're spelled and pronounced very differently. So I can't say they're equal. I say they're not equal. And the way that we interpret that is by saying there's no real solution. You could try every positive, negative, every fraction, every decimal, every value of x, and no matter what you plug in, the left and the right will never be equal. Next question. This is a lot of f's, but I'm going to use my DCI again. So starting by distribution. I'm going to leave the 5f and 3f alone for now, and I'm just going to rewrite them and take care of my brackets. 5f plus 3f minus 2f minus 6 equals 6f minus 6. Now I can combine my like terms. 5 and 3, subtract 2 more, that gives me 6f take away 6 equals 6f take away 6. Well, I'm going to subtract away 6f from each side now. That'll leave me with negative 6 equals negative 6. Well, of course it is. Does that mean my answer is negative 6? What if I added 6 to both sides? Now I have 0 equals 0. Does that mean 0 is my answer? What this is trying to tell you is that there is more than one answer. What I just highlighted is the key, and if you hit that point, you can stop. Because what you realize is the left and the right are the exact same expression. That means it doesn't matter what you plug in for the variable f, the left and the right-hand side will always be equivalent. This is a mathematical identity. So if you wanted to finish off this problem and make your teacher happy, please tell them that there are infinite solutions for f, or state that f is all real numbers. Now that students see that there can be no or infinite answers, they start to forget about this next example. So I'm going to again use DCI. I see that there's no distribution. I've got no like terms on the left, no like terms on the right. So what I'm going to start to do now is just to get rid of that 12 by subtracting it. That leaves me with 20e equals 2e. And at this point, students will sometimes stop and say, oh, that can never be equal. How can 20 of something be 2 of something? But you're wrong, because we can go further. I'm going to subtract away 2e from both the left and the right-hand side. What that's going to give me is 18 times e equals 0. If I want to undo that multiplication of 18, the inverse operation would be division. So e is equal to 0. It doesn't mean there are no solutions. It means that the solution is 0. That's it for this video. Thank you very much for watching, and I'll catch you on the next one.